today I am going to talk about the Romberg integration, and for this, consider we want to integrate the integral if we want to integrate this integral f of x dx from a to b, and say when it is approximated using trapezoidal rule, then this integral, it can be approximated as h by 2 f of a plus f of b, right? And plus some error will be there. So that means it is th, let us call this as th, and plus some error, and this error can be written in terms of h. Say it is a2h square plus a4h4 plus a6h raised to power 6 and so on, and let us call this as equation number 1. So here th, here th is trapezoidal approximation of the given interval with step size, that is b minus ay, and let us call it as h, right? And let th0 is equal to th, means th is represented by th0. Now the integral I, it can be written as th0 plus a2h square plus a4h4 plus a6h6 and so on. Let us call it as equation number 2. And let us take another estimate. Let us take another estimate with step size b minus a over 2n, and let it be equal to h by 2. So therefore the integral I will become th by 2. Here we have approximated the integral with smaller step size, means earlier it is h, now we are using h by 2. So with this more smaller, I am moving towards the more accuracy. So error will be a2 h by 2 square plus a4 h upon 4 plus a6 h upon, let me correct it, h by 2 whole 4 plus a6 h by 2 whole 6 and so on. That's what we are getting, and let us call it as equation number 3. Let me simplify it in much more manner. So it is th by 2 plus a2 by 4h square plus a4 over 16h4 plus a6 over 64 h raised to power 6 and so on. So this is the equation number 3. So now we will apply the operation. Let us apply an operation. What was that operation? Let us have a look at it. At what operation we are now applying. So we will apply the operation, that is 4 times equation number 3 minus equation number 2. So that means it is 4i is equal to 4t h by 2 comma 0 plus a2 h square plus a4 h4 by 4 plus a16 upon 16 and h raised to power 6 and so on. And here this is this part which I am writing now. I am writing down the equation number 2 here. So it is th0 plus a2h square plus a4h4 plus a6 h raised to power 6 and so on. Now let us take their difference. So when we take their difference, this will become negative, this will become negative, this will become negative, negative and negative. This will cancel out. So now I can write it down as this as 4 minus 1 I must be equal to 4th by 2 comma 0 minus th0 plus a4 by 4 minus a4 h raised to power 4 plus a6 over 16 minus a6 h raised to power 6 and so on. And this can be written as that I is equal to 4th by 2 comma 0 minus th0 upon 4 minus 1 plus a4 by 4 a4 h raised to power 4 1 by 3. This 4 minus 1 is 1 by 3. This goes to here plus 1 by 3 a6 by 16 minus a6 h raised to power 6 and so on. And this integral I will become 4th by 2 comma 0 minus th comma 0 upon 4 minus 1, and let us call this as b. 4 h raised to power 4 and it is b6 h raised to power 6 and so right. So let us call this as equation number 4. So now proceeding in the similar manner, or I can simply write it down as let us call this term as th by 2 comma 1. So if we call it like this, then this integral I will be equal to th by 2 comma 1 plus b4 h raised to power 4 b6 h raised to power 6 and so on. Here t is equal to th by 2 comma 1 is equal to 40h by 2 comma 0 minus th0 whole upon 4 minus 1. This is its value. So let us call it as equation number 5 and it as equation number 6. So this is corrected. This is corrected trapezoidal formula. This is corrected trapezoidal formula using Richardson's extrapolation technique. At level 1, and here truncation error, truncation error is of the order of h raised to power 4 as clear here, because the term containing h square has been eliminated using this approximation, and if we proceed in the similar manner, so proceeding in the similar manner, we can eliminate we can also eliminate h raised to power 4, and the integral I will become 16t h by 4 comma 1 minus t h by 2 comma 1 over 16 minus 1, and this is plus c6 h raised to power 6 and so on. This we can write it down as h by 4 in comma 2 plus c6 h raised to power 6, and similarly we can eliminate h raised to power 6. Similarly, we can eliminate h raised to power 6, and I can be estimated as that I is equal to t h by 8 comma 3 plus d8 h raised to power 8 and so on, where t h upon 8 comma 3 it can be written as 64 t h by 8 comma 2 minus t h by 4 comma 2, and it is 64 minus 1. So in general form, it can be written as t h by 2 raised to power j comma not j but I comma j is equal to 4 raised to power j t into h over 2 raised to power I comma j minus 1 minus t h over 2 I minus 1 comma j minus 1. That's what we are getting, and whole divided by 4 raised to power j minus 1, and let us call it as this part as, if I call it as in the more simplified form Rij, then Rij can be written as t h over 2I comma j, and which is equal to 4 raised to power j r I j minus 1 minus Ri minus 1 comma j minus 1 whole divided by 4 raised to power j minus 1. So this is the required formula, and let us call this as equation number 7. So this is known as Romberg integration formula. Romberg integration formula. Also we know that R00 is equal to h by 2 f of a plus f of b, and using this we can directly write down Ri0. Let us write down it directly. I am not going to derive it. So in the similar fashion, Ri0 can be evaluated as Ri minus 1 0 upon 2 plus Hi summation k is equal to 1 to 2I minus 1. It is f of x to k minus 1 for I is equal to 1, 2 and 3. right? So these are the two formulae, or these are the two equations. This is the equation number 7 and this is the equation number 8. These are the two things which we have to keep in mind, and along with this, right? So to do integration, we have to remember these equation numbers 7, 8 and 9. So these are very important equations which we have to or we will use to compute the integrals using Romberg integration, right, method. So for this, let us do an example. So example is this, that you have to compute the integral 1 to 2 1 by x dx. You have to compute this integral using Romberg integration, right, up to R22, right? So let us have a look at it, that how it can be done. So let us start with the R00 now. So R00, it can be estimated as h by 2 f of a plus f of b, where f of x is equal to 1 by x and a is equal to 1, b is equal to 2, right? So let us take h is equal to 2 minus 1 by 1. Let us take, so it is 2. So h by 2 means it is 2 upon 2. H we are taking is as 2 minus 1 by 1, so it is 2, and it is f of it is 1 by 1 plus 1 by 2, and this value comes out to be 0.75, right? Now let us try to find out R11, and this R11 can be written as 4 raised to power 1 using equation number 7. 4 raised to power 1 R10 minus R00 whole upon 4 raised to power 1 minus 1, 4R10 minus R00 divided by 4 minus 1. Now here we need to evaluate R10. So using equation number this 9, we can evaluate this R10. So R10 can be written as R00 by 2 plus H1, k is equal to 1 to 1, f of x1. So it is R00 by 2 plus H1 f of x1. Now what is x1? x1 is equal to a plus b by 2, means it is the midpoint, means 1 plus 2, their midpoint will be this x1, and h1 is basically h by 2, right? So let us put their values. So it is 0.75 divided by 2 plus h1 will be h by 2, means, and h is basically 1, so it is 1 by 2, and f of x1 means x1 is basically here the 1 plus 2 by 2, so it is 1.5 we are getting, so it is 1 over 1.5, right? So it is 0.7083333. This is the value, right? Now we have evaluated R10. Now let us substituting this value in this equation. So when I put this value here, and we know that what is the value of this R00, so that means R11 is equal to 4 times 0.7083333, right? And minus 0.75 divided by 3, so its value comes out to be 0.6944, right? Now let us evaluate next value. Next is the R2 R21, and R21 comes out to be 4R20 minus R10 divided by 3. Now we need to evaluate this R20 because this is already known to me, but this is not known to me. So let us evaluate it. So R20, this R20, it can be written as R10 using equation 9 by 2 plus H2 f of x1 plus f of x2, right? So now let us try to say we have to find out the integral from 1 to we have to determine the integral from 1 to 2. Their midpoint is 1.5, which we have evaluated. Now x1 is basically the midpoint of these two, so it comes out to be 1 plus 1.5 by 2, and similarly x2 will be 1.5 plus 2 by 2. So now it will become, this x1 will become 1.25 and here it will become 1.75, which we will use now. And h2 is equal to h by 4, so it is or h by 2 raised to power 2, so it is 1 by 4, right? So if we put their values here, then this will become, this portion will become, this is equal to R20 is equal to 0.708333 divided by 2, 1 by 4 plus 1 by 4, f of 1.25 plus f of 1.75, right? And let us put their values, and if we put their values, then it will become 0.6970237. So therefore let us substitute it here, and when we will substitute its value here, then it is 4 times 0.6970237 minus 0.7083333 divided by 3, and this, after doing little algebra, it will become 0.6932536, right? Now everything was there. Now using all these results, we can calculate R22, and R22 will be 16R21 minus R11 and 15, and all the values are with us as we have evaluated these. So let us put their values. So it is 16 into 0.6932538 minus 0.694444 whole divided by 15, and this after simplification will become 0.69317444. So this is the required value of the given integral evaluated using the Romberg formula, Romberg integration, right? So this is all about it. You can also compare it with the actual results, and you can also estimate the error. So it's an exercise for you that what is the error in this calculation. The calculation of this particular integral, right? So you can do it at your own. So that's all for today's lecture.